Thanks, Larry. Thanks, Rob.
Thanks, Larry.
Thank you all. Thank you, Larry. Yeah, my name's Dave Dye. I'm with DFD Architecture. We do sustainable building design. And this evening we have to talk about water heating and advanced ventilation. Our Tim Gaughan, sorry, make you an artistic name. Gaughan of RHEEM, who will talk about water heating, and Newell of Equinox, who will talk about advanced ventilation. So Tim will lead off, and so I want to give Gaughan will lead off. He is so thank you all for coming this evening. And Tim is a 26-year veteran of RHEEM manufacturing, has held numerous positions, all focused on driving efficiency product solutions. Currently has a responsibility to introduce and promote high efficiency and energy-related water heating products to the utility and builders. Tim is a graduate of the University of Dayton, my hometown, where he earned a dual bachelor's degree in both management and finance. So thank you for talking this evening. Please go ahead.
Well, thank you, David, and thanks everyone for joining this track. And I must admit, I am humbled. Oh, wait a minute. Oh, I've been made the presenter. Okay, there we go.
Okay, very good.
Okay, all right. Thank you, David. Thank you for the introduction. And again, I'm humbled and honored to be invited to speak at the Net Zero Conference. And let's talk about hybrid heat pump water heaters, the way to a net zero home, right? So a little bit about RHEEM. We are international as well as a national manufacturer that make heating and cooling products. You may be familiar with us. And as I said, there's a lot of factors being in play here, such as economic and environmental, and it's all about sustainability. So we have a company have actually taken that position as well. And we have significant goals, as most states have now, for decarbonization and getting away from fossil fuels. In 2025, our goal is to launch a line of heating, cooling, and water heating products, 50% reduction in greenhouse gas, degrees of efficiency. And that's what really we're here about, right? And basically, we want zero waste as a manufacturer by 2025. It's all about a green planet. And again, we're all about training as well. So let's get into this, okay? RHEEM is the only company that actually, if you look at all the things that use energy in your home, of the products we make represent 65% of that. Okay, so we really have to take a very proactive stance in regards to what, not only what is the economy trending towards, but what's best for the environment as well. Okay, and that's what leads us to hybrid heat pump water heating. Okay. Water heating is the second highest energy user in the home. It's the most efficient way to heat water, bar none. How it actually operates is you're actually capturing residual heat that's already been produced. So it really, no energy is utilized in order to heat your water. And the cost savings on an annual basis is significant compared to a standard glass on steel resistor element heater. Now, how does a heat pump actually work, right? So a heat pump water heater, it draws the ambient temperature from where it's installed, and it needs, in order to work properly, it needs 700 cubic square feet of air, and it draws that heat from the air of where it's installed, and it goes through an evaporator coil. Now, the evaporator coil absorbs that heat and then forwards it to a compressor. The compressor increases that heat up to 150, 160 degrees. And what it does then is the refrigerant that is in those coils goes around the outside of the tank. And the heat in that coil then goes from the outside of the tank and is absorbed by the water in the tank. Okay, now the coils are not in the tank due to the aggressiveness of water. So again, it's built for longevity as well. Now let me introduce you to the Proterra. The timing of this conference could not have been better. We just introduced a brand new platform of water heating called the Proterra in July. And as I said before, we have a significant footprint in all channels throughout the United States, and they're just starting to show up in the market now. So what is it about the Proterra? Okay, we built this, what we call our three legs: smart, sustainable, and savings. Savings will be a recurring theme throughout this presentation. So let's deal with smart. Okay, we know as a water heater manufacturer, typically, there are two concerns to the plumbing trade when they get a phone call about a water heater. Either it's leaking or there is a problem with an element, okay? Or with a gas product, it again could be similar as well. So we provision this heater with a leak guard, automatic shutoff, that actually turns the water off to the water heater in the event there's a leak. Now, the leak sense is tied in with the leak guard. So the leak sense actually will notice that there is leaking coming out of the tank. Integrated Econet Wi-Fi. Econet is nothing more than our terminology for connectivity. Now, this unit can be provisioned on a smartphone. So the homeowner will have full accessibility to control this water heater. And it provides a variety of information also of how the unit is running. Remote control, that's tied in with the Econet. And of course, from the trade's perspective, this will actually provide, is the compressor running properly? Is the element health indicator? Is there something going on? So again, it's automatic information. And of course, hot water availability. Now, I have an 18-year-old and a 20-year-old. 20-year-old's off at college, right? But I remember growing up, dad's always the last one to be in, right? So like, okay, take a cold shower. And that's terrible for a water heater manufacturer employee. So what this does, it actually doesn't tell you how many gallons are available, but it indicates to you, hey, maybe we ought to wait a little bit in order to take a shower. Now, what's the second leg? Sustainability. This model has the highest UEF rating in the country. Okay, we actually have a model that goes 4.0 UEF. Now, for those of you that are not familiar with the universal energy factor, a standard glass line electric water heater typically top out at about a 0.9293, where the UEF on a hybrid heat pump water heater, our Proterra, goes to 4.0. Carbon footprint reduction. What does that mean? That means it takes less energy in order to operate this unit. And I'm going to show you a slide coming up that will actually tell you and show you how this compares. Okay. Energy usage tracking. That's right. We actually show you how much energy you're using on a weekly, monthly, and yearly basis. This is what utilities look at when they're provisioning rate schedules. And some of you may not be aware, but there's winter rates. In some areas, there's summer rates, okay? This actually provides the homeowner the ability to modify their usage in order to be more in line and save money. And of course, Energy Star rated, that's a given. Now, the third leg is savings, okay? Saves money and energy, that's a given. Energy saving time of use. This is more of a utility-driven feature. However, the homeowner can provision this unit to actually put it in the most energy-saving mode during the time that they're paying peak rates. Built-in demand response. This is specific to a utility in regards to the utility having a say-so in regards to the operation of your unit itself. And of course, vacation and away mode. So I'm going to show you the different models that were just released. So we actually have 3 different variations of the Proterra. Now, the first one is the hybrid builder model, okay, for those of you that are in new construction. And no, you're not seeing that incorrectly. It's a 40-gallon. We're the first in the country to come out with a 40-gallon. although previous models and manufacturers also have 50, some have 65, but most also have 80. This product also has integrated Wi-Fi built into the unit, meaning there is a Wi-Fi chip built right into these models, okay? Zero clearance requirement. That means it can be installed in a closet, provided it does have access to 700 cubic square feet. That means you utilize louvered doors, right? Widest range of ambient temperature. In previous presentations, okay, they talked about not subjected to the cold outside. Remember, water heaters are in the home. So whatever you have your house set at, that's the temperature it's going to be utilizing in order to heat the water. And the range of temperatures, this model will go down to 37 degrees and the heat pump will still act properly. It can even go up to 145 degrees. If the temperature drops below 37 degrees, there are built-in thermistors in this unit that will turn the heat pump off, and that's to preserve the functionality of that heat pump, but the elements will kick in. That's where the hybrid comes in. Less than a 2-year payback. Meets NEA Tier 3, which is a Pacific Northwest tier for qualification, and it is leak detection ready, meaning that it doesn't come with a leak detector, but a part will have to be provisioned on it. Now the flagship one, the Proterra itself, okay, this one goes up to a 4.0 UEF, and that really is our 80-gallon model. This model also has a CTA 2045 demand response ready. This is a utility specific, which is an open source communication port that is built right into this unit. It is the quietest in the country at 49 decibels. It provides automatic maintenance alerts, $4,800 energy cost savings over a 10-year period of time. That's the 10-year warranty. And leak detection and shut-off valve ready. Okay, and this model actually hits the NEA Tier 4 because of the 4.0 UEF. Now the last model is the Proterra with the leak guard and leak sense. It's nothing more than the leak guard, which actually turns the water off to the water heater itself because it is a pressurized vessel, which will virtually eliminate the leak. And the leak sense is what actually monitors and detects the leak that sends a message to the leak guard. So size, how do you size this, right? So for a 50-gallon, an average water heater typically is going to give you 70% capacity of straight hot water, whatever you have it turned in on, let's say 120 degrees. So what that does is basically give you 4 8-minute showers, okay? But don't forget, you're mixing it also with cold, so you're getting a little bit more. On a 65, 5 8-minute showers, and on an 80, you get 6. Now, the one thing I'll tell you with a hybrid heat pump water heater compared to a traditional resistor element heater is that its first hour delivery is 6 to 8 gallons more hot water. So it's actually giving you more hot water as well as excellent efficiency, far and beyond what a standard resistor element water can provide. Now, this is an eye opener. This is the return on investment, okay? Now, some of these numbers may not be relevant to your market, but I've used this as an example. Now, the initial investment is fairly close to the Michigan market. You're looking at a 50-gallon at a 30-amp service. You're looking around $1,200. And like I said, these are available in most all channels. Now, a traditional 50-gallon resistor element glass on steel unit is around $420. Now, the annual operating cost is the eye opener. Look at what it costs for a hybrid to operate over a year versus what a standard electric. That is eye opening. So $4,800 over a 10-year period of time. So it literally pays for itself in 8 months, okay? Now, the one thing I do want to bring to your attention is that you want to reach out to your local utilities and their trade ally network. There may be incentives out there that you definitely want to take advantage of. But the one thing I know that is present is there is a $300 tax credit available on this unit this year. And it was available last year as well. I've actually put a link on the top, and all you have to do is pull up the IRS Gov form, and actually you can print out that form, okay? So you can save additional dollars. Now, gas, okay? I'm in the Midwest guy, and I know Midwest has a significant amount of gas. appliances out there. But I've already showed you, these are actual energy guides taken off our products. So if you see the Proterra at $104 annual operating cost, that's a 50 gallon. The energy guide next is a 50 gallon under-fired gas unit. So it is less than half in order to operate a Proterra versus a standard gas unit. Now, what type of messaging is this relevant to a homeowner? Okay, it's all about connectivity. If they, and also provides alerts and notifications. Not only would they get alerts and notifications over their phone, which is a free app you can get from the App Store from RHEEM, but it also gives you audible alerts, okay, if those that don't want to connect to it. And of course, demand response scheduling, there is a way to provision this unit to actually save more money. Sustainability, again, it's heat that's already there. It does not have to be created, okay? And it reduces the overall carbon footprint, so it's environmentally friendly. And there's your savings again. Builders. Okay, space-saving design. I don't know how many builders actually get more money for large utility rooms, okay? And they're getting smaller and smaller, so that you can literally install this unit in a closet. Sustainability. This product actually improves a HERS score. If those that may not be familiar with HERS scores, that's the overall, simplistically, it's the overall energy envelope of the home. The Proterra will improve that score anywhere between 4 to 7 points. And of course, there's your savings again. Now, I'm going to give you a view of what the interface looks like to a homeowner when they're in front of the water heater, okay? Now, I can read every one of these, but I'm not going to do that. What I do want to bring to your attention is the mode section, okay? Where it's up in the left top corner where it says current mode. So let me explain what that is, okay? You have the energy saver mode. That's the default mode. This unit will always provision itself to the energy saver mode, meaning that the heat pump is actually activated first, and then the elements will rotate. It's not simultaneously wired because the amperage draw would be too great. However, they will cycle back and forth depending. However, if it is actually sized correctly for the right amount of people in the family, then really the heat pump will be the primary source of generation of heat. You can actually provision the unit to put it in the heat pump mode. Now, the heat pump mode will take a little longer to recover, but it uses minimal amount of energy, minimal, okay? High demand mode. High demand mode means that you know you have people coming into the house and you know you're going to be using more hot water. Therefore, the heat pump mode will activate and the elements will cycle back and forth. So you actually get a lot more hot water than you would in any other mode. The full electric mode is that you're taking the heat pump provision out of the unit altogether. Why you would do that, I don't know, but it is a mode that's in there. Now, the vacation mode, you can literally go on your app or go in front of the unit itself, put it in the vacation mode. The unit will go to 65 degrees, okay, and it will stay there for 28 days. After 28 days, it will go back to the energy saver mode. That's the default mode. If you put it into high demand mode or the electric mode, within 10 days, it will go back to energy saver mode, meaning it will continuously try to save the homeowner money to get to net zero. And again, there's your modes of operation in regards to the efficiency and recovery, okay? As you can see, the energy saver mode is the best choice. That's why we made that the default mode. Now, EcoNet, okay? As I said, we do provide a free app, and once the homeowner loads that app, these are the type of things that are available to them, okay? Everything that they saw pretty much on the screen itself of the unit, they can see now on their phone. And I want to actually talk about two different parts of this. First is the scheduling and the usage reports. So what does scheduling mean? The scheduling feature allows you to go into that water heater and you can actually put what temperature you want it to operate at and which mode you want it to operate at. Now, if you looked at the previous screen, you could see the heat pump mode was indeed the most efficient mode. So people are creatures of habit. So if you look at the times that have been identified on the phone, in the morning, they have the temperature up a bit in the heat pump mode. However, when likely they're gone, they dropped the temperature down in the tank and they left it on heat pump. But at 7 o'clock, they upped it a little bit and they kept it in heat pump mode. So what you're actually doing is replicating pretty much what utilities see from the consumer. Okay. So usage reports. Okay. Again, it provides you a real timely snapshot of how much energy you're using and what days. So you can actually modify your behavior to lower your overall electric bills. Physical installation of the unit. You can duct these units, okay? I'm going to suggest in the state of Michigan, you do not duct these to the outside, okay? However, you can duct them into non-usable spaces. Now, most homes have attached garages, okay? And most garages don't get below 37 degrees. And if you remember in my presentation, I said that there's a built-in thermistor, okay? So you can actually vent this 125 feet with 8-inch, okay? And it's a very inexpensive ducting, okay? Now, why would you duct it, right? Because we have found that 95% of the installations are not ducted because most have 700 cubic square feet of air, okay? So it's that 5% because, as I said before, it captures the residual heat. Therefore, it dispels about 6 to 8 degree air lower temperature, okay? But it dissipates fairly quick. So again, you can go 125 feet with it. Now, let's say you don't want to duct it, okay? You can actually, like I said, just put it in a closet as long as it has louvered doors. And again, you can get as much air from a louvered door as you could with 700 cubic square feet. So that is the conclusion of my presentation. I have kind of summarized just a little bit there, and there is my actually my contact information at the bottom on the right-hand side. And I welcome if you have questions, and there'll be a time after this presentation that obviously I'll stay online as well and see if I can answer anything you may have. So thank you very much. And David, I pass it back to you.
Thank you, Tim. It was very great. Learned a lot, actually. So thank you very much for that. Good to know about a hybrid heat pump water heating. Now, our next person is Dr. Ty Newell. He will be presenting smart ventilation and healthy homes. And he is co-founder and co-owner of Build Equinox, a company devoted to inventing technologies for healthy, comfortable, and sustainable living. He retired from the University of Illinois in 2007 as an assistant dean in the College of Engineering and is an emeritus professor of mechanical engineering. Ty's degrees are in mechanical engineering. He graduated in 1974 from the University of Michigan, as did I, and got an MS PhD in 78-80 from the University of Utah. He has lectured around the world on indoor air quality, comfort, solar energy, building energy efficiency, and resource conservation, including a keynote address at the Solar Energy Society of India's Silver Jubilee. He lives in a 100% solar-powered home, has 2 Fords that are also electric, and is the first home within Illinois to be permitted, municipality to be permitted for rainwater harvesting. So, and he also has a Equinox building that is 100% solar powered. So he talks the talk and lives the walk. So I will forward it on to Dr. Newell. Thank you for presenting to us tonight, Ty. Thank you. Now we have to turn on the microphone. I can't hear you.
No, Ty, can you try unmuting yourself?
Unmute yourself. Unmute. I can't hear you. Hit the, see if you unmute.
There we go.
Ty? Is he there? I mean, after smart ventilation and healthy homes. Screen? I don't know if I, what? Oh, I can't. Oh, it's on your screen. I don't know how to. Is there any way you can unmute him?
So he's unmuted from my side. Clearly there's something on
Oh, do I have him
his
muted?
end
I
that's
don't
not
think
working.
I do.
Nope, he is not muted the console side.
On mine.
Oh, I can hear you.
Try that.
There
we
we
go.
All right.
Okay, worked.
Isn't technology great? So, yeah, Dave and I found out that we're on campus at University of Michigan simultaneously, probably protesting oil embargoes and streaking across the diag at the same time. So
It's all a
but
shock to me.
We won't
So thank
talk
you,
about that now. So yeah, thank you very much for appearing here, everyone. Let me see if I can get my screen adjusted. So it's a pleasure to come here. I am a Michigan native, but I'm coming to you from central Illinois, and my relatives are scattered along M53 from the heart of Detroit all the way up to Marlette. And so, so I'm a Detroit fan through and through, and always will be. So as far as this talk, we'll talk about smart ventilation and healthy homes. And you can see the three of us who co-own what we call Build Equinox. Ben, who's my son and my boss, and his main challenge is trying to keep an employee like myself focused and on task. And then Alex Long, who's a co-owner. And I just enjoy working every day with these two young people who are motivated for the right reasons and doing things great. So let's see if I can get screen mode here too. And we're almost there. Looks like, there you go. My computer has to think a little bit like I do. So we're driven by, in the words of Aldo Leopold, how do we live on a piece of land without spoiling it? That's the best way to describe it. So I live in a 0+ house, and I work in a net zero business, and I drive electric cars, as Dave mentioned, that are powered by the sun. And so I'm pinching myself that took me several decades to get there, but everything's there that we need for moving into sustainable living. Our company, Build Equinox, manufactures this, what we call Serve 2 now, the second generation unit that's been on the market for a couple of years. And in the words of Lawrence Berkeley Laboratories, houses are dumb without smart ventilation. And our goal, rather than thinking of us as a ventilator, we are geared toward how do we live in a healthy manner? How do we feel well? And to us, that means health, cognition, sleep, which is so important for our health and well-being, and then our productivity. So everybody's got their own definition, but as far as smart ventilation, in our words, a smart ventilator should measure indoor pollutants, and in our case, carbon dioxide, which is the key to knowing if your air is fresh. You can't smell healthy air. You cannot smell a contagion. And to automatically ventilate when needed. Take the stress off you of wondering you should open a window, turn on a vent fan, be on speed 6 or 7. That it, just like a thermostat, takes care of your air quality. Whole house air recirculation and filtration is essential. One and done ventilation strategies have been promoted by others. Most particulates in a home, and certainly contagions, are generated indoors. And so it's essential to recirculate that through a filter in the house and get rid of those particulates. And when it's nicer outside than inside, bring in, just like automatically opening a window, bring in as much fresh air. You can store fresh air. So when you have a smart ventilator that sees, hey, 2 in the morning, it's actually pretty nice out, bring that in, fill your house with fresh air so that later in the day, when it's not so nice, you can delay or possibly eliminate needing to bring fresh air in at that time. High energy efficiency is important, but we tell people think beyond energy. People are more important than energy. We want to do energy in an efficient manner, and we want to supply it in a sustainable manner, but we look at energy as a constraint, not as the objective. And then archive and analyze indoor air quality data. This day and age of automatic and over-the-air monitoring and control, as we were hearing about heat pump water heaters, my data can help you, your data can help me, my data can help me individually, but this is how we'll learn to continue improving devices into the future for our better health, comfort, and well-being. And just like today's car, I mean, it's very complex, and our serve units have a lot of technology, very complex. But if it's smart, that means it's unobtrusive. It's doing all those things in the background and basically letting you live your life instead of worrying. And worrying is bad for the stress, worrying about if things are okay. And then over-the-air upgrading. We introduced this about the same time as Tesla several years ago, but this allows us, as we come out with new features, for our existing customers to broadcast those features, broadcast the new analytics, and they can then enjoy the new features we're bringing out, like ultraviolet air sanitation that we recently announced earlier in the summer. And then, of course, like everyone else, hey Google, hey Alexa, you'll be seeing this soon, but I'd like a little more fresh air. I'd like you to do this. I'd like bathroom. I'd like the master bath to be fresh air ventilated right now. So that's rapidly being developed, and we'll be announcing that soon. So here's where I live and work. Build Equinox, what we call Equinox House, is my house. That's where I am right now, and takes inspiration from Frank Lloyd Wright's Usonian homes, but also from Alden B. Dow, one of the most wonderful architects ever from Midland, Michigan. But this is a SIPS house, and Alden Dow was the innovator and inventor of the foam core SIPS. And but our house is basically a simple 2,100 square foot ranch, 0+. It provides electricity for all the house needs throughout the year, about 9,000 kilowatt hours, plus enough for about 6,000 to 8,000 miles of EV driving per year. And then our business, which is a net zero business with about 8.5 kilowatts of solar, a 2-axis tracker, and a stationary one in the back that we call sundial. But our business is a 4,500 square foot Morton building. And the air quality is exceptional, both where we live and where we work. So you can have your cake and eat it too. You can have high performance. Here's a selection of a few homes, but a number of these are passive homes, like the first passive house in Metro Denver, first passive house in South Carolina, first passive house in Florida. And then these were mod homes, which you can read a very detailed report on their energy of 13 identical homes, manufactured homes. They're excellent energy efficiency, 13 identical homes that we monitored on an hourly basis over 2 years. So the most detailed data you'll find on air quality, comfort conditions, and energy, from microwave ovens to heat pump water heater to any other electrical load. And these homes are 20% more efficient, exceed what's required by both flavors of passive house, FIAS and then FEE, by 20%. Most buildings are unhealthy. Most homes are unhealthy, and we pay the price for it in sick days, in asthma, in allergens, and in contagions. And the problem is that they don't properly get their fresh air in a reliable manner. they're not properly filtering. A MERV 8 will not take out contagions. A MERV 11 will start to, but really you need MERV 13, 16, or HEPA 16 and HEPA are equivalent. And then the possibility of using air purification like ultraviolet to actually kill the microbes. And so there's not a good intersection of these. And it is an absolute myth that a leaky house has good air quality. A leaky home, from our field measurements of many, many homes, do not have good air quality. Where the leaks occur and where you live are two different things. Bedrooms are often very well sealed and very poor air quality, as I'll show. We need to intersect these three things, and that's what a good smart ventilation system like ours will do, so that you get the proper fresh air, which should be double of what the current fresh air standards are as far as ASHRAE and Passive House at 0.3 air changes per hour. These are supposedly adequate, but they are not. They're not satisfactory. And you can see that we've been writing about this for many years now. And now, of course, with everybody's awareness of pandemics and contagions, that this is essential for getting air diluted so contagion concentrations have less probability of making us sick. Air filtration, proper filtration, MERV 13 is what we recommend as a minimum level to remove about 90% of particulates, and most are generated in a home, as well as removing droplets and particulates that have contagion on them. And then air purification, adding in something like an ultraviolet bulb, in our case about a 16-watt bulb, which is less than a penny per hour of operation per person in a home, but has about an 85% single pass kill efficiency. And when you integrate these features together properly, that fresh air, say, diluting the air by 50%, a filter knocking out 90% of what's recirculated, and an ultraviolet getting rid of 85% of what's left, you find that microbes can be knocked down to well less than 1%. Well, let's talk about health costs briefly relative to energy costs. If you take roughly the housing stock of the US, 100 million homes, and if they reach this level of low energy, very energy efficient use, we'd be at, say, about 4,000 kilowatt hours per person per year, about the level that Passive House is aiming for. And that would be about $160 billion per year, assuming standard utility rates, but what renewable energy can easily supply now at this cost and spread over the US population. You find that that cost is about $160 billion per year, and about 80 billion plus or minus 20%, depending on north or south, for climate conditioning and ventilation related, and about 80 billion for people. Hot water, as Tim was describing, cooking, and other things that we like to do. And annual costs of seasonal influenza and colds pre-COVID, about $130 billion a year in sick days and medication, doctor visits, and things like that. So they're of similar cost, but as we'll talk about, a bit more fresh air, and we can knock this down by a significant amount. And asthma now affects nearly 10% of the populace, and that means 1 out of every 3 to 4 homes has someone who's afflicted, and more than likely, you or someone you know has asthma. And one of the difficult things for anybody with any respiratory sensitivity is walking through a door of a building and wondering if they're going to have an attack. And with smart ventilation, you can at least make your home a safe refuge that you can enter with the assurance, with the peace of mind that you're going to be able to breathe. It's being taken care of. And then the big dog, at least until COVID, now COVID, $2-3 trillion cost and counting. but 10% decrease of human cognition with a value of about 1.5 trillion per year using standard ventilation practices. And you can read a couple of papers from Harvard School of Public Health regarding this, both the calculation of that cost as well as how it impacts many areas of cognition productivity. This study by Donald Milton, done about 20 years ago, and you may be seeing him on the news quite often. He's faculty at University of Maryland, but he is very very high-level spokesperson on airborne diseases, been studying them his whole career. And this particular study was done with a company with over 3,000 employees scattered over many buildings, and they sorted among buildings that had about 40-50 CFM per person, about double standard ventilation, and those that had, say, ASHRAE 62.1, 62.2 ventilation, nominally about 20 CFM per person. By going to 40%, by going to 40 CFM per person, doubling it, which has a cost of about a penny per hour of employee, and that's very insignificant, and that's without any energy enhancement, any energy recovery scattered across all climate zones of the US, that this would have a 40% sick day reduction with minimal costs. So one sick day, roughly about 40% of sick days that people take, that has about $500 value. That's less than $50 per employee as far as that value. And incidentally, that level of sick day reduction is equivalent to what the influenza vaccine typically reduces sick days. Here's a 1950s era home. Nothing special done to it, hasn't been renovated. 2 adults, 3 kids, 3 bedrooms, 1950s construction, radiant heating. 2 of the kids that share a bedroom go to bed. Look at what CO2 does. It just goes screaming up here. And CO2 is a tracer for contagion and the probability you're going to get sick if an infectious person is sick. We recommend holding it at 800 parts per million to get to minimize the transmission probability of influenza and COVID. This house just floating along, again, a leaky home. It hasn't been sealed, it hasn't been had any additional insulation added since 1950. It's way up here. One child gets sick, the other one's going to get sick. The reason CO2 comes down is that at about 9 o'clock, once they quit chattering and are asleep, that the parents open the door.
So we'll have to wrap it up.
Okay, I'll do that. So let me just say then, as far as certified passive house, but with one and done ventilation, no recirculation, and no smart sensors to know when you need it or not, typically polluted in the areas where people live. When this couple went away for about a week and a half over his 3-week period, it was fine. It was over ventilated. When they're home, it's not. Here's a smart ventilated home being kept with about 800, 850 ppm sensor. So let me just say lots of features can be added so that somebody turns on a kitchen fan, this wireless signal, so we have Wi-Fi built in, plus we have local wireless similar to Bluetooth, but something called N-Ocean. It's a protocol that's rapidly growing in the US, but dominant in Asia and Europe. But it chirps a message when you're in the bathroom with an occupancy sensor, when it's a local CO2 sensor or a switch sensor, and it will then put it into ventilation. So I'll end on this. Smart ventilation is part of what we call a concept of pre-ventilation. And pre-ventilation is, it focuses on our health and our comfort. And with smart ventilation, coupled with environmental data, coupled with biometrics, what you've eaten, your activities, coupled with what you've been doing, coupled with big data, artificial intelligence, we know that as we merge and fuse this information together, that perhaps we're going to be able to tell somebody a few days ahead, if you keep on this track, you're going to have a migraine. You're going to have a bout of depression. You're going to have an asthma attack. Try doing these things to maybe mitigate, maybe avoid those things. And so I'm going to leave it at this. These guidelines, which you can find at Green Home Institute, a couple of webinars on how to protect yourself against COVID spread, as well as other diseases, but monitor carbon dioxide, keep it below 800 parts per million. If it's above 1,000, 1,200, get out of that building. Good filtration, at least MERV 13, and then potentially ultraviolet. And I'll leave it at that, and we'll go on to questions.
Okay, thank you very much, Ty. That's very appreciative. That's also very informative. We'll have question and answers. Thank you both, Ty and Tim. Let's see, ZeroNet. We have some questions here for Ty or Tim. I guess I'm not seeing in the chat room. Let's see. It's there.
And, while we're looking, let me just mention, most homes that we go in have heat pump water heaters, many of them RHEEM, which is right now the top unit, without a doubt, with connectivity, the efficiency, the quietness. And we get packaged often with mini splits, now the ducted mini splits, which is integrated in with a serve where we operate the mini split, but you can compress a serve, a ducted mini split head, and then a heat pump water heater in a very small mechanical space, much less than 750 cubic feet, because the serve will ventilate that space and keep it conditioned so it doesn't become a walk-in cooler. And so that to us is the foundation, the three foundation stones of a home. Heat pump water heater, a good efficient heat pump comfort conditioning system, whether geothermal or mini split, and then smart ventilation.
Now, are you, Ty, that's ERVs are the other way to refer to them. And that's just, you're just adding the S as in a smart ERV as a way to condition the air with it.
Yeah, no, we're not an ERV. We use a heat pump to do the energy exchange. And so we have about 1/3 of a ton heat pump, and lots of information on our website to see that. But for many reasons, many ERVs, which also do a moisture exchange, and then HRVs, which don't do the moisture exchange, but we don't like having a polymer heat exchanger in there that many of them have these days. And there's many reasons, from microbes growing on them, difficulty cleaning them, frost protection required. We like frost on our heat pump because, of course, we're squeezing and converting energy out of that condensate and frost and turning that into space heat during the winter. And so, yeah, we start with a blank sheet of paper, and our DNA, our background is in heat pump development. Our little company and our consulting company, we're all mechanical engineers, but we designed the first air conditioner that's certified for being connected to the new F-35 fighter jet. That's about a 30-ton air conditioner. And so we know heat pumps in and out. We know how to build them so that they can operate in Yuma, Arizona, and Nome, Alaska, and so our ventilation units are scattered across all climate zones in North America.
Thank you. Tim, would you like to say anything more before? I'm being told we need to go on to track one, but I wanted to give, Ty had an opportunity to say something at the end. Tim, did you want to have any closing remarks?
Well, first, again, thanks for inviting me. And Ty, I learned quite a bit from your presentation. And I really want to continue wearing my mask now everywhere I go until I know and are convinced I have good airflow and air quality.
Exactly.
Well, thank you, Tim, and thank you, Ty. Appreciate it. Thank you all for coming this evening. And I hope you are a lot more informed because I am also. So thank you for coming. Please move on to track 1.